Really appreciate the opportunity to be with you all today. Thanks for the invitation. My colleague and I were part of a team of six regional fire specialists spread across the county extension offices of the state of Oregon, serving multiple counties. So today our presentation is using GIS applications and analysis to inform community and landscape wildfire resilience. Next slide, please. So kind of an outline of today, some of the topics that we'll cover will be some GIS applications relevant to wildland fire. GIS analysis serves as an essential tool to characterize fire hazard risk and potential fire behavior at scales ranging from large landscapes down to individual properties. GIS analysis informs collaboration on how and where to prioritize landscape scale treatments for wildfire resiliency across federal, state, tribal, and private ownerships. And finally, GIS plays a critical role in communities' wildfire response and recovery. Next slide, please. So, for those of you who may be unfamiliar, the cooperative extension model are the land grant universities of the United States. That would include, in the case of Virginia, Virginia Tech. But there are 1862 institutions, as they're called, and then there are also the 1890 historically black colleges and university, usually in the southeastern United States, and then the 1994 colleges and universities that are tribal colleges and universities. And so cooperative extension serves almost 3,000 counties across the United States, and it is the cooperation of federal, state, and local government, counties contributing as well as state through their land grant universities, and then um, the federal government with U.S. Department of Agriculture and the National Institute of Food and Agriculture. One of the main elements of extension work is in natural hazards and also in emergency preparedness, response, and recovery. And so, kind of across program areas, there's an extension disaster education network, Eden, and then also there's an association of natural resource extension professionals nationwide. And within that, there are different initiatives, including one on climate change, but then there's also the National Extension Wildland Fire Initiative as well. Next slide. So I understand that some of you may have a great deal of background in wildland fire, or it's been the course of study for you. Wanted to start out with INCIWeb is an incident information system. And so you can go to this website and have updates on fires that are occurring across the United States. And clicking on those icons allows you to, see updates on, size, complexity of fire, resources assigned to the fire, any community evacuation orders in place. Sometimes, depending on the number of personnel that are assigned to a wildland fire incident, it's updated, multiple times a day, or sometimes once a day, depending on the size and complexity of the fire. Uh, Next slide, please. Another major important resource for researchers as well as others is the monitoring trends and burn severity. So there was in this particular case, the screenshot is taken of the Echo Mountain Fire Complex. So this is coastal, mid-coast Oregon. The Labor Day 2020 fires, they burned over 800,000 acres in the Cascades. And there was a relatively small fire, 2,500 acres in extent, but because of the amount of infrastructure and houses, even small fires can have great impacts. So this impacted over 360 some structures. There were evacuation orders in place for most of Lincoln City, which is right on the coast there. The fire was being pushed by an east wind event from west or from east to west. The Lincoln City Hospital actually had to be evacuated during this fire. Um, and right now, with extension in Oregon, we are undertaking a landowner experience after fire to understand how uh, individual property owners are recovering from wildfire. And so when we're conducting site visits and we're generating maps for those property owners, if their home was in a perimeter that is part of the monitoring trends and burn severity, we made sure to include maps that showed the burn severity across their property. But it's a useful tool to understand burn severity. Next slide, please. For the state of Oregon, we have the Oregon Wildfire Risk Explorer. There's a Pacific Northwest quantitative wildfire risk assessment. And as you can see, the area I serve is the northwest portion, thank you, of Oregon, and Micah's over in the Blue Mountains area. But it's really only low to moderate hazard where I am. But this map has generated quite a bit of controversies. Um, it's a task that was assigned to the Oregon Department of Forestry by the state legislature, and then there was support given by Oregon State University faculty and staff in terms of its development. But there's been a lot of pushback from property owners about the map, consideration of irrigated lands and other considerations, and then also a lot of pushback from county commissioners and state legislators. But this is nonetheless a useful tool to see wildfire risk. And then also the Oregon Wildfire Risk Explorer has some other tools, like you can generate reports for individual properties. You can also generate reports for watersheds and for county level or other community level that might assist in the development of a community wildfire protection plan. The existence of a community wildfire protection plan is often a prerequisite for any grants that might be applied to, be they public or private funds. Next slide, please. Um, so you saw in that previous slide, kind of Northwest Oregon, only low to moderate fire risk, and then particularly in Southwest Oregon and Eastern Oregon, areas with, elevated fire risk. So this was a publication undertaken as part of the creation of the fire program itself and generating 6 different wildfire risk assessments showing overall relative risk for the 6 ecoregions that my colleagues and I serve as regional fire specialists. And as you can see in A for what Astoria to Florence, again, only low to moderate risk depicted in that uh, previous slide, but in this slide, it's actually showing that there are areas of highest risk even in the coast. Um, and then all of the fire service areas have areas of high risk. Next slide, please. Um, so there are HVRAs are highly valued resources and assets. And so just wanted to show this table in terms of a breakdown for that data that's in the previous slide in terms of those categories, including people, buildings, infrastructure, agriculture, timber, habitat, species, and water. And then the HVRA subcategories, and then also the scaled valuations across our fire service areas. Next slide, please. Within the Oregon Wildfire Risk Explorer, within its legend, there is a breakdown. You can depict fires based on Karen Short's data since about 1992, which is useful. But Oregon Department of Forestry manages a fires list that is within ODF ArcGIS Hub. And so this is since the early 1960s. This is point data showing, as well as attribute data showing fires across. This is Northwest Oregon, where the Columbia River enters the Pacific. Um, so this shows a little bit more rich data in terms of fires across Oregon compared to some of the other newer interfaces like the Oregon Wildfire Risk Explorer. Next slide, please. But this is really useful using that data set. You're able to see attribute data like, was it low elevation or higher elevation fire? Was what the extent of the fire was? There's a lot of different attributes to that data. What I wanted to emphasize was that while the state of Oregon is about over 50% comprised of federal lands, in the case of Columbia County, which is just to the northwest of Portland, Columbia County is over 91% private lands. And it's also got, variable wildfire risk over time in place. But generally, Oregon Department of Forestry and local fire departments are trying to keep those fires very small and contained. And usually, fires in Northwest Oregon only get out of control when there's preceding drought and an east wind event or a red flag warning. Um, but this is to show that, over 1,000 acres has, almost over 1,300 acres have burned across Columbia County since the early 1960s, over 1,000 fires. So they're trying to keep those fires small, usually under an acre. About 95% of the fires in this area are kept at under an acre. But this was a data table that I derived from that previous slide of the ODF ArcGIS hub. Next slide. Your individual states may have similar data sets across the United States managed by the State Forestry Agency. So within my fire service area, just to the west of Portland, there is Washington County, the second most populous county in the state. Hag Lake is a Bureau of Reclamation reservoir, and uh, there are Washington County public parks that are managed around Hag Lake, recreation facilities. Hag Lake supplies irrigation and drinking water to most of Washington County. Next slide, please. And Hag Lake's really been identified as a priority cross-boundary landscape. So this is the tax slot type data. And it shows around Hag Lake, you have an Oregon State University research and demonstration forest, the Madison Tract. You have large industrial timber. You have small industrial and small woodland. You have residential woodland. There are also local governments and utilities as well as residential. So a lot of different kind of land ownerships. And I really want to stress how key the cross-boundary nature of fire is. Next slide, please. There's also IFTDSS, the Interagency Fuel Treatment Decision Support Center system. And so you're able to download this program, and there are introductory courses on using the program. You can run risk assessments. You're also able to compare different weather scenarios. So this is really important. Like I said, for Northwest Oregon, if you're looking at the Pacific Northwest quantitative wildfire risk assessment and the Oregon wildfire risk map, Northwest Oregon, it's all low or moderate fire risk. But using this IFTDSS, you're really able to parse out and show that there might be great, much higher risk than depending on the scale compared to what that kind of large statewide scale is. Next slide. So with um, Oregon State University Extension Service, the fire program, as well as other colleagues consultants. We created a report for the Tualatin Basin, which is most of Washington County, including Hagg Lake, a wildfire risk assessment. And this is the IFTDSS model processing. That's a first step in developing a risk assessment. Next slide, please. So this is showing fire history in Washington clouding, including fire starts from 1961 to 2022, and then perimeter areas of fire. So the pink perimeters are the Tillamook burn that were a series of burns. It was the 6-year jinx, 1933, 1939, 1945, and 1951, burning about 360,000 acres in burns and reburns. And then point data since 1992. What I wanted to point out in this map was that oftentimes, depending on the data set, there may be really important fires that are omitted. So, for instance, this map is able to show the fire perimeter for that 1939, the second Tillamook burn, also known as the Habo Mountain Fire. But in the case of 1939, simultaneous to the Tillamook 2 burn was the 14,000 Dutch Mill Canyon fire, and that's not depicted. And that occurred in the area of Scappoose, right next to the Columbia River, heading directly from east to west towards that Banks Vernonia State Trail. But yeah, I wanted to show that the data sources that we have for fire oftentimes might omit really important fires that occurred historically. And we know about the Dutch Mill Canyon fire because, it's in archival data and newspapers. Next slide, please. So working within this basin and to protect Hagg Lake as a water resource, OSU Extension and other state agency partners, local service districts and fire departments, as well as utilities and Stimson Lumber have done a lot of educational programming and have more educational programming to prevent fire ignitions around Hagg Lake. There have been a number of fires that, again, were kept small because of the efforts of Oregon Department of Forestry and the local fire departments. But it's been incredibly important to work with local, state, and federal agencies, as well as private and nonprofits, to prevent fires from affecting the water resources of Washington County. Next slide. So here's kind of a timeline just to show that, not everything is created in a day. There was the 2014 Scoggins Creek fire that, impacted over 214 acres of Stimson lumberland and got within about a mile of the municipality of Forest Grove's water supply. And then 2021, you had the Tualatin uh, quantitative wildfire risk assessment that was conducted. Local service districts and OSU Extension Fire Program and consultants. 2021, you had ignitions at Hagg Lake, including during red flag warnings, again in 2022. And then in November of 2022, Oregon Department of Forestry convened local partners. And then in March 2023, Tualatin Soil and Water Conservation District convened those partners again. And we had stakeholder meetings throughout the course of 2024 and developed a Hagg Lake wildfire event with information tables, demonstrations, and speakers on the 22nd of June of this year. Next slide. And then in terms of response to fires, GIS plays an incredibly important role. This is the State of Oregon Fires dashboard that indicates evacuation levels. So it's ready, set, go in the case of Oregon. Ready means, be ready. And then set means like you should definitely have your car loaded. And if you feel unsafe, you should leave. And then when you get the go order, you should leave. And sheriff's departments, oftentimes, in collaboration with emergency personnel as well as fire departments, are the ones who are but sheriff's deputies and police are the ones knocking on doors to have residents evacuate. But GIS plays a key role in planning those evacuation levels. Next slide, please. And I will hand it over to my colleague.
Yeah, thanks, Aaron. So I'm going to talk a little bit about how we use GIS to prioritize landscapes in Northeast Oregon, acknowledging that, we don't get much precipitation out here, very dry, very different than Aaron's region on the coast over there. So fire is widespread, across our landscape here. So just want to say why do we prioritize? Well, years like this show us why we have to be, strategic with where we place our funding to, reduce wildfire risk. So this is a private property I visited this year. Oregon had a record-setting fire season. 2 million acres burned. Of that, about 1.8 million of those were in Eastern Oregon. So it really gets us. We have limited money to spend, and we have these huge fires. We got to prioritize where to do it. Who prioritizes? Well, our landscape out here, Northeast Oregon, the forest land is overwhelmingly national forest land managed by the U.S. Forest Service. We do have quite a bit of private land as well, and so the Forest Service kind of does their prioritization. And then where I kind of work is with a group of partners. It could be nonprofits, local agencies, state agencies, watershed councils and private landowners to prioritize that private land because they don't have all the resources that the large agencies do to prioritize. And where we prioritize, we generally try to start where there's values at risk, structures. Old growth forest is a big value out here because most of that was logged off in the 1900s. We look for critical stream habitat for various wildlife species, and so basically work for those values at risk, and then move out in the landscape. So try to protect communities, and then move into more of like a landscape resilience look. So with that, I'm going to talk a little bit about how we go from this huge landscape of Oregon down to prioritizing, a discrete project area. So this is a quantitative wildfire risk assessment that Aaron showed earlier, and like he said, it's at the state level, his area doesn't look super risky, but as you zoom in, it does. My area is very high fire risk from any scale. We only get anywhere from 16 to 25 inches of rain per year. A lot of that falls as snow and such. So we have very seasonally dry landscapes. So we look at the state of Oregon and know that we're not going to prioritize all over a huge area like this. So let's take it down to my service area. So these are the 9 counties that I cover. I'm based here in LeGrand. And as you can see, the dry landscape, all this dark green, we have quite a bit of forest land, but also a lot of agriculture land along the Columbia River. And then we have a lot of rangelands. All this kind of dry brown is grass, shrubs, juniper, basically non-forested areas. So we put the risk assessment on there again, and wow, still it'd be hard to prioritize this huge landscape. The dark red's the worst, but basically anything with this orangish color or darker is pretty high fire danger there. So even though there's a variety of colors, pretty much everything that's not this yellow color is pretty high fire risk out here. So when we think about where we actually prioritize, mostly it comes down to the county level. So this is Union County, county I reside in, LeGrand here, and we usually prioritize the lands or at the county level because that's where we have county governments work at that level, various nonprofits work at the county level, watershed councils. Often their watersheds fall mostly within one county, so just like a manageable landscape that we can actually do something meaningful in without getting too overwhelmed. So again, put the wildfire risk on there, and yeah, all this is high fire risk. This valley here, you can kind of see it in this previous map, mostly agriculture. But then once you get out of that, it's forest land and rangelands that really burn anytime it's dry. So when we think about prioritizing where to start in this county, we often start by looking like what's the Forest Service doing on their side of the fence. So I don't have the ownership on here, but this outer portion of the county is almost all Forest Service, and as you get close to the valley, it gets more into private land. So looking at these green polygons, these are just for the sake of discussion because I didn't have the actual data on hand, but I created these as theoretical projects that the Forest Service are working on. So we try to complement cross-boundary work like Aaron was talking about because we acknowledge that fire does not recognize property boundaries when it burns. So we got to treat both sides of that ownership boundary there. So when I look at this, I say, wow, there's a lot of projects going on up here. Let's take a closer look and look at the landscape. So we see these projects here. These are generally fuels reduction treatments aimed at protecting communities from wildfire. That's all on Forest Service land. And then you see down here is where we start getting into communities, agriculture, and then like a kind of a mishmash of forest land, rangeland, and ag. So when I put the ownership on here, if you look at all the light green, this is Forest Service federal land. All the yellow is private land, and all these black lines are tax lots. So what our ownership matrix is usually follows this pattern. We have Forest Service at the high elevations. You come into these larger tax lots, which are usually industrial forestry companies that manage heavily for timber and not much else. And then you get into these smaller tax lots, which are, small woodland owners, ranchers that own range and forest land and use it for grazing, and then other people who just kind of want their little slice of land out in beautiful Northeast Oregon. So right here, we have the town of Elgin. This is the town of Embler, and the town of LeGrand, where I'm at, is down here. So this project area is up in the top here. So when we look at this, we see, okay, Forest Service treatments going on, lots of private land, both industrial land and non-industrial land. This looks like it could be a good project area. And we do a lot of looking at these different fire risk models, a lot of more local ones too, but that's just kind of a broad overlook. So we take that and we zoom into about this portion of the county over here, and we line up a project area. And this follows usually generally around the county boundary, but you can see we want to acknowledge that, fire doesn't follow that boundary either. So we're actually capturing more of the watershed boundaries, as well as some of the kind of the socio-political spatial dynamics as well that exist out here. So won't go into depth, but a lot goes into creating this project area. So after we have that, we want to look. So like I said, I generally work on the private land side of things because they don't have a lot of resources. And so this project area, all this light green is private land. This is both private industrial land, which is generally kind of this outer portion here, and then private non-industrial land, which is, your typical small woodland owners and ranchers and such. So we got to figure out, just because we have this project boundary designed here, we need to somehow figure out what's going on there from a fire hazard standpoint, because this is still over 100,000 acres. And we, if we're lucky in a single year, we might treat just a couple thousand acres on private land in an individual county. So lots more land than we actually do. And we want to make sure we get a good bang for our buck where we're putting our treatments. So to figure out where we want to put our treatments, some of the things that influence fire, fire hazard, and how fire will burn when it comes to a certain piece of land, we have the overstory forest conditions, which are generally like, do we have ponderosa pine that's open space and probably good from a fire management standpoint? Do you have this really dense mixed conifer forest that you imagine you throw a match in there in the summer and it'll just burn like crazy? And then we want to look at the understory, which are what trees exist underneath that tree canopy, because those, if there's continuity from the ground up to the higher forest canopy, that'll, result in generally more severe fire. And then we went to surface fuel conditions. So what kind of flammable fuels are sitting on the ground, the tree or the logs, the branches, the needles, anything that's sitting on the ground that can burn, shrubs and grasses, all that kind of stuff. So we can start off with what we can do, spatial from the GIS from a remote standpoint, because this is a whole lot of land to get across and do, forest inventories and figure it out all on the ground. So what we'll do is, so for a second here, ignore the yellow lines and think if you're looking at this landscape, this is just a piece of that larger landscape. So you see this all forested in here, looks, like pretty, consistent forest, all this brown and lighter green stuff. This is our rangeland, so grasses, shrubs, some juniper trees, stuff like that. And so we need to somehow break this all up into something we can understand. So we go through here and we want to figure out, how do we design polygons where the fire hazard conditions inside this polygon are different than this neighboring polygon here? Because when you look at them, that looks pretty similar to that right there. So it's hard to figure out. So we'll first start by just putting the boundaries where the tax lots are, because we have to acknowledge differences in ownership, and we're going to be creating a product for the landowner out of this that I'll describe later. But how do we actually determine that this is different than this piece, and why did we draw that line right there? So we can take even a smaller subset of this and we can look, and so there's some obvious differences here. You have dense forest throughout all this. We have more of a meadow forest complex here. This is either a road or a power line. So there's some easy differences to spot out there, but you really can't see the fine nuances. So we can overlay this with, topography, we can aspect, slope. We can use various fire hazard models and models that predict vegetation and such. But one really helpful one for us is these canopy height models, which if you're familiar with LiDAR and LiDAR point clouds, you can generate this model to where it basically gives you the distance from the ground up to the tallest height of the vegetation. And this is on, I think ours is on about a 3 foot spatial resolution. So as you can see here, all the tallest trees are going to be in red, and the shortest vegetation is going to be in green. So that's mostly grass. That's that road or power line here. You got meadow here. And you can start to see how we actually delineate this. So if you get really used to looking at the stuff, you can see that, some of these red ones have larger canopies. So not only are they tall, but they're broad. So that generally, gives an idea that they're older trees, more mature forests. And you can imagine drawing a polygon, something like that to capture that area. Another one would be around this dry meadow forest complex. This is a young stand of trees here. And so you kind of train your eyes to see those things. And what it results in on a property basis, this is our Obertupfer for Research Forest. It's OSU managed out in the region. We have these classified stands that we can actually think about, okay, now that we have separated these into similar vegetation here, different vegetation over here, we can actually start to understand what's inside those without doing a really intense inventory of all this land that would just take years to accomplish. So with that, really important part of this project is we do got to get out on the ground to do some of this verification and to look at those understory trees and those surface fuels that I talked about earlier, because those are the things we don't have readily available data to figure out from a GIS standpoint. So what we do is we create those maps in ArcGIS online, and we use Esri Field Maps, which many of you are probably familiar with. That's an app on your phone that you can take maps you create online and collect data in the field. So we do this just so we don't have to, collect it and say something like Avenza or something else and enter all the data again. When we enter the data in Esri Field Maps, it automatically populates our maps on our ArcGIS online in our databases. So this is that same Obertupfer forest. And as you can see, when we have this stand delineated, we do a community engagement outreach event, which I won't go into detail in, but we get landowners to some of them agree to let us come on their land and verify what we're seeing, using this satellite and aerial imagery. So when you get out in the field, you select a polygon and you just walk a short line through it. You wouldn't do what we traditionally do in forestry is put a network of plots that would take probably all day just to inventory this one property. But we can do this whole property in about 2 hours using this method. So we get out in the field and we say, okay, this is a warm mixed conifer forest. Is 30 to 150 years old. These are things that we took a guess from using our GIS data, but now we're verifying on the ground. We want to know the stocking because that's really important for forest management, is like how dense are the trees, how many trees are there, is it within like the recommended range of what we call a healthy fire resistant forest. And then we don't have these filled out in this one, but we'll do mortality, how many trees are dead, and how many pockets of dead trees do we have. What are the understory tree species, understory density, and then we'll get to that surface fuels aspect that I talked about as well. So this is all, saying that we can only know so much from that, 1,000-foot look from the sky. So we got to get down on the ground and do some checking here to verify that. And what we can come out with is this great product where we know the forest type, we know the stocking, and we can actually populate this map with all kinds of different things. We can put on the surface fuels on it, or say, are there a lot of down trees, down logs, a lot of litter and duff, which are basically decomposed materials and stuff that sit on the forest floor. And we can kind of create this picture of, what is a fire risk in any one of these stands, and it can give us enough information to prioritize a little more at the landscape level. So at the landscape, so this is the southeast corner of that big project area. This is where most of private lands sit. So all of these polygons on here that are colored in are properties that landowners have given us permission to come on and field verify our data. So it's really important to have property owners' permission. Like out here in Northeast Oregon, there's a lot of distrust of government, a lot of skepticism about people coming on their properties. So as part of that outreach, myself from a university extension service, I'm pretty well trusted by the community because I'm not regulatory like agencies are. So myself, nonprofits kind of get together with these agencies to present the landowners about this project and try to gain some trust, because all of this data is, or all this work is a little bit useless if we don't get to actually, field verify it. So when we do that field verification, we're able to take that overstory tree density, the understory tree density, and the surface fuels and put them into a framework we created to say, okay, if these conditions can exist in this polygon, is this a high fire hazard, a moderate fire hazard, or a low hazard? And that's what you're seeing here. So all the red you're going to be looking at is high fire hazard. This orange is moderate and the green is low. So as you can see, a lot of our stands are red. 80% of the stands we've done in this project so far are red. And that's just typical of our region. We have a long history of fire suppression. Fire would have been a really important process in this landscape before Euro-American settlement in this region. So it's not uncommon to see a lot of areas need treatment. But what we can do with this, even though we haven't got all the landowners across the landscape to participate, we can start seeing some areas where we have engaged landowners in high risk area, high hazard areas that we can start putting some fuel break treatments in and some things that may protect the community. So right there, that is really fairly contiguous area. There's a road right there. That's somebody led a survey as well. That's the area where you might put a fuels break treatment to thin out the forest a little bit. And then if a fire is coming down from the mountain here into the community, we could potentially stop it there, or vice versa. If it's happening in the community and it's going to threaten our national forest land, that'll help there. Another one right here. And in theory, if we could treat this, if we could do a fuel break in these properties, one right here and one right here, we'd have pretty good community wildfire resilience, because we also have a fuel break up in this area on industrial forest land and some more work on national forest land outside of that. So you start to build this picture, but to actually do these treatments and with the funds we have available, we have to get the buy-in from these landowners, on these particular parcels. So we actually, as part of this project, after assessing their land on the ground, we give them this whole long packet with a bunch of maps and information. And two of these maps are really important in communicating this fire hazard to landowners. So this is just the cover type. So it gives an idea of, like, on your property here, all this green is ponderosa pine. These are dry meadows down here. We have riparian areas, and kind of gives the landowner perspective that they probably haven't seen before, because most landowners don't have the money to pay someone to create a map like this. But the more important one is we take that same map and we overlay it with the restoration focus, which is basically just the equivalent of fire hazard. So higher hazard, more focus on restoration. So all these cross hatches represent that restoration focus. So the X's are high fire danger. Not a great map here, sorry about that. But these horizontal hatches are moderate focus, and then these double cross hatched are low. And all this does not have an overlay because it's rangelands and other stuff where there's no forest to treat. So that's where we'd send them to a more rangeland focused agency. So when you look here, and this property owner, say his house is right down here, if he sees this map and says, wow, all of this is a huge liability. If fire comes in here, that's going to be threatening my house down here, because the biggest thing that destroys structures are embers coming in from fires. So you can't tell the slope on here, but all of this is uphill of his house. And so, that is going to stimulate landowners to think, wow, I really do have an issue on my property, and I maybe should work with these agencies to, figure this out. So just want to review this process for you. So we identify a landscape and we identify the private lands on there. This is where we're going to focus our efforts for this given year or two. We delineate those into individual stands, where we can start to gain an understanding of, how we actually are going to classify this landscape. We actually go out in the field and we address it on the ground, do a quick field verification. This is me, actually. This is an old growth pine tree, probably 600-800 years old. Not many of those on private land, but this one was on national forest land. And then we actually present that into a meaningful structure. We can look and prioritize the landscape. So once we have that, our agency, folks like Natural Resource Conservation Service and Oregon Department of Forestry, want to know how to prioritize. So first we give them this. This is a dashboard just showing what are the cover types across the landscape. And like I said, only a subset of these are actually field verified. So the real tool that we use to really get at what's been verified is, I'm going to exit out of here, pull that out of the way. And we have the stand query tool. So all of this is our project area on private land. This is all the national forest land, the gray up here. So say the Natural Resources Conservation Service, who funds most of the forestry work in our region, says we have this grant coming in and we are going to be able to treat warm mixed conifer forests with a high understory tree density, because we want to do a pre-commercial thinning, which means they go out and they cut most of the trees under 8 inches diameter, because those are contributing the most to the fire hazard in our region. So we can go into here and we can say, okay, we want our overstory species to be warm mixed conifer. And then we also want to get at that understory density, which is understory overall density. And we want that to be dense. And we can actually query this layer, and only the stands that fit those two attributes and are also field verified are going to show up. So if you're a funding agency, rather than going out and talking to every landowner and looking at every property, if you already have this this tool available, you can look and say all of these highlighted areas fit my grant requirements. So I'm going to say, wow, we have a priority area up here, from our agency administrative objectives and such. So I'm going to zoom in, click on that, and I have all this information about this stand of trees. So it's warm mixed conifer. It's 30 to 150 years old, and it's heavily stocked. It's a white fir and grand fir in the understory, which is often a big issue in our region because these are not fire resistant trees. They're the trees that don't do well with fire, so not the ones we'd like to have there. So we just have this whole thing, shows them all that. So it's a really useful tool for our agency partners. So going to jump back into this, and just wanted to quickly speak. So my role with this is kind of, I do a lot of GIS work, but don't have time to do all this. So we have some GIS analysts locally that do a lot of this work, and I generally work on landowner outreach, helping guide the GIS process, and as well as providing oversight of the whole project. So I work closely on this project with a nonprofit, with the Soil and Water Conservation District, and with our Oregon Department of Forestry. So it's really a collaborative effort, just like Aaron spoke about in his region. And we have just a second here, so I'm just going to show you guys are probably familiar with story maps, but another great tool for communicating what's happening to landowners. So this is about collaborative restoration on one of our national forests. And so we can take this, we can show them, people are coming together. I used to do dendrochronology research. We can show them how we know fires burned when. So those are all historical fire scars from the 1800s and 1700s. And we can kind of give them this visual representation of like, this is what, oops, sorry about that. Let's see if I can get that. This is what our landscape would have looked like, historically. And then if we go down a little bit more, oops, let's see. Okay, not finding it very well. Oh yeah, this is what it looks like now. Dense trees, lots of down fuel, and large fire hazard, and we can kind of return it to something like this. So just wanted to briefly show that story maps are a really powerful tool that, like I said, many of you are probably familiar with and are pretty widely used this day and age. So with that, we're getting about to our time. So that's kind of the end of our presentation, and I wanted to thank all of you for watching, and we'll kind of move into questions in a minute here, but just wanted to say feel free to reach out to Aaron or I if you have questions. We're happy to share what we're doing out here. So with that, I guess I'll stop my share and turn it back over to Becca for Nate.
Thank you so much. I will, if people have questions that they want to put in the chat, we'll read them out for Aaron Micah to answer.
So we have a question that's asking, do you have any additional advice for or any comments about working across community parcel or other boundaries to address wildfire issues based on your experiences?
I'll jump in, and then my colleague can follow. But I would say that the GIS piece really serves as a power visualization tool for the public and private sectors. And you might have agencies or service districts, or private, and they're all looking at it from their perspective or lens. And GIS is a really powerful visualization tool to aid in that conversation. And it really does start with partnership. You're going to find that you're able to contribute different things within your areas of expertise or within the purview of your agency. And then, um, as Micah said, you've got in the terms of extension, we have a real advantage in terms of any kind of anti-government sentiment, whereas they might see the, Oregon Department of Forestry or another state or federal agency as, being regulatory, or top down. And with extension, we're able to have a lot of credibility in terms of working with private landowners because we're non-regulatory. Yeah, I'll stop there.
Yeah, I'll just add to that. Yeah, that partnership's super important, getting everybody in the same room. And for the private landowner side, usually it's historically been agencies making decisions for private landowners, and that has built a lot of this distrust out there now. So get them in the room as well, have them give their feedback. Even, some of them are really educated in this stuff, some of them are not, but all their opinions matter. So learning together, doing together, being in the same room, going on lots of field trips, and just, it's really important if somebody's not in the room from a particular type of land ownership. If Forest Service is never there to speak with the landowners and such, you're never going to have that social license to do this cross boundary work. So those relationships are just absolutely probably the number one thing for me, at least.
Awesome. Are there any prescribed burn associations in either of your districts, and do either of you work with them?
So currently, in the case of Oregon, there are prescribed burn associations, particularly in Southwest Oregon. There is the Rogue Valley Prescribed Burn Association, and then there's also the Umpqua Prescribed Burn Association, and a recently formed Southern Willamette Valley Prescribed Burn Association. Prescribed burn associations are private landowners getting together to burn on private lands, sometimes with nonprofit or agency support. There are a lot of them in California. They've also proliferated in Washington. Um, right now, speaking to my fire service area, on the coast, there's definitely a lot of pile burning that occurs on the coast, but mostly it's agencies that are burning for restoration of coastal meadows. Um, in the case of the northern Willamette Valley that I do serve, which is, oak savannas and prairies, there is interest in both the mid Willamette Valley as well as the North Willamette Valley in the formation of prescribed burn associations in those areas. And so there's actually an Oak and Prairie Summit for the Willamette Valley that's going to be occurring at Oregon Department of Fish and Wildlife in Salem, the capital of Oregon, and I'll be giving a flash talk on prescribed fire and PBAs, prescribed burn associations, and then also facilitating a breakout session towards generating interest or serving landowners in terms of PBA formation. So right now, I would say I'm more working on the support and the creation, hopefully, of those prescribed burn associations, and I'll hand it over to my colleague.
Yeah, we're in a similar spot out here. There's not much prescribed burning going on private lands, really none outside of pile burning, and tons of landowner interests. Our colleague, like Aaron mentioned, in Southwest Oregon, has done a lot of great work down there. But out here, we have a much smaller population, not as many resources. So we actually meeting with the landowner actually after this meeting today to talk about forming a PBA because the only way we're going to get prescribed fire out in the landscape on private lands is like landowners coming together and doing that stuff. So, I think we all hope to have many of them throughout the state, in the next 5 years or so.
Thank you. So what advice would you give to students that would want to focus on fire ecology or get into it as a career or just as an interest?
You said students, Nate?
Yeah, some like students that want to get more into it, what resources and just any advice that you could give students.
Yeah, I'll start with that one. So I would say the biggest advice is get out there and see the diversity of, fire ecology work and jobs that's out there. So, when we think of fire ecology, I think, at least I tend to think research based. But like Aaron and I showed, we use, fire ecology principles through a lot of our work as, we do a little bit of research, but, most of our stuff's not that. So, go, I don't know, depending on the area, what agencies, organizations, nonprofits and such, but I am a huge advocate of shadowing folks in that world and try to get a broad perspective. So if there's opportunities to go out of state and see how people do it in different regions, that's a great way as well. Definitely read the research, but I think if you see like a researcher you really like what they're writing, reach out to them because most folks in the research world are willing to talk with students and talk to them about everything that goes into that 10-page document they wrote because they'll start to reveal this kind of whole world of work that goes into creating a publication like that. But get out there and do it, and then also try as hard as you can to get out and see some kind of live fire. I really would say prescribed fire is a easier thing to get into rather than trying to become a wildland firefighter for a season that might take a bigger investment. But go out if you do have local prescribed burn associations or other and see live fire occur, because there's often this disconnect between the research we have and what actually happens on the ground. So if you can get that perspective from both that high level research side, as well as seeing how fire actually burns across the landscape, can really fill in a lot of those those gaps and those disconnects that happen between the two worlds. So yeah, Aaron, anything to add?
Oh, that's a great overview. I would say, in terms of coursework, I'd say broad coursework across disciplines is really important as well. Biogeography, landscape ecology, um, they might be offered in geography or biology or forestry departments. A lot of the National Wildland Coordinating Group requirements to, be red carded or become a wildland firefighter are all available online and they're free. So you can, pursue the trainings through the NCGG as well, besides college coursework. Um, and then, yeah, get out there and see what opportunities are available with, local, state, and federal agencies. There's actually a wildland fire apprentice program that I just recently became aware of. It didn't exist when I finished my undergraduate. But yeah, you can literally be paid, by the federal government and learn many aspects of wildland fire, everything from outreach and engagement to, emergency response to kind of public affairs or public information officer role. Um, and yeah, the prescribed burn, I think it's really important to, form communities around fire, and it's going to take different forms. In the case of the Southeast is probably the most prodigious burners of land on private land across the United States. It's like 200 to 250,000 acres a year that they're burning. So I think the shift from like Smokey the Bear to Burner Bob has been a really positive development. The other thing too, you never know how you're how I arrived in this position was a really windy one. My background is as a geographer, but I'm a returned Peace Corps volunteer, and I actually, received wildland firefighter training from the park guards of Machu Picchu Historical Sanctuary that train park guards and volunteer park guards and community members across the country because they're the most highly trained themselves. And then, when I was at Mizzou, Shannon was at Mizzou when I was there as well. I worked with the U.S. Fish and Wildlife Service at the Big Muddy National Wildlife Refuge, and um, yeah, the it's not just the Forest Service that's doing prescribed fire. The Fish and Wildlife Service does a lot of burning for habitat as well. They did it at the Big Muddy. They do it within the wildlife complexes of both the coast of Oregon as well as the Willamette Valley. So, look for those opportunities, volunteer, intern, seasonal employee. Um, yeah, hope that helps.
Aaron, in your part of the presentation, you mentioned omitting historical wildfire data from your data sets. Is there a reason why you do that?
Oh, it's not that I'm omitting it intentionally. It's just that the kind of existing data sets that, Oregon Department of Forestry might have, Oregon Department of Forestry has historic data sets. So those included the, multiple burns um, of the Tillamook burn. But in the case of that data set, you have to be aware what that data set might be omitting itself. I've tried within my capability, like with Institute of Natural Resources of Oregon or other sources, if I notice that there is something omitted, I try to contact directly to, who the owner of that data is so that they can rectify that or at least include that caveat within their metadata. It's not intentional on my part. It's more like in the case of the Dutch Canyon fire, I don't know that there's a fire perimeter that has actually been created to depict that fire. So, maybe based on the archival data and any notes from foresters or agencies at the time, I could work with partners to create a polygon to depict that. But it wasn't a conscious decision to omit. I'm just trying to call attention to multiple sources. Well, the being in the field, as my colleague mentioned, is incredibly important, that field verification. But also, I would say another aspect of verification is that historic record. So, yeah, I have an ODF data set, but then when I look at, old uh, articles from journals that, American Association of Meteorologists, they have a perimeter of the 1933 Tillamook burn, but it wasn't just Tillamook County burning. In Clatsop County, where I'm based, there was a 47,000 to 50,000 acre Wolf Creek fire. And so there might be journal articles that are depicting both the Wolf Creek fire and the Tillamook burn of 1933 at the same time, but that ODF data set is again only showing the Tillamook burn perimeters. I hope that makes sense. Let me know if I can explain that better.
Um, if there aren't any more questions, we are getting to the end of our time, so we can start wrapping it up. Just so everybody is aware, the next CGA event is next week on November 20th. It's our GIS Day event. We will be hosting a brown bag, which is a more casual conversation. Feel free to bring your lunch to talk about GIS after graduation. And we will also be running a GeoGuessr tournament all day. So if either of those things are interested to you, please come and hang out on GIS Day. And thank you so much to our speakers for coming in, and thank you for everybody who attended our speaker series.
Thank you all.
Yeah, thanks.